Okay, guys. Okay, let's look at this particular question on Hess's law. So they have given this equation: urea is a naturally occurring substance which can be hydrolyzed, given by the equation. So the equation is given for you. Okay, so we need to apply Hess's law to solve this question. Okay, and when we look at the information given for us, okay, there are standard enthalpy changes of formations given for us to solve this question. Now, when we look at a solution, okay, it comes to calculation involving Hess's law, there are three main methods that you can use. Okay, so I will go through all the three main methods. Okay, so therefore the first method, okay, is going to be the typical triangle type of cycle. Okay, so I will show you. This is going to be the conventional way of solving. I will also show you, okay, the second method, which is going to be the rearranging, okay, rearranging the equation. And I will also show you the third method. Okay, the third method, you can actually call it Mr. Gopi's method. Okay, or I'm not actually claiming this particular method. It is one of the method, okay, that you can use to solve any questions related to Hess's law. Now, so let's actually look at the same question. So I'm going to go through the same question, and we are going to apply the three methods. So let's actually look at the cycle. Okay, so let's actually construct the cycle over here. So first of all, we will start with the equation. Okay, the given equation in this particular question is this. So we are going to copy that equation. Okay, so I'm going to rewrite the equation. So H2O, okay, CO. Okay, for this particular example, I'm not going to write the states so that we can save some time over there. But states are very important. Please take note of that. It is important to double check, okay, whenever we solve these questions. And now, okay, what I'm going to do is, okay, just to make it easier, okay, I'm going to put two boxes over here, okay, just to differentiate the products and the reactants. So I'm just going to draw the two boxes over here. So the first box, okay, on the left is going to be your reactant. The second box on the right, okay, is going to be the product. Okay, so now, okay, what we are going to do is, according to the equation, they are talking about formation. Now, it is important to know that to form, let's say, for example, I have A reacting with B to form C. Okay, it is important to notice that the arrow is actually pointing towards C. Yeah, to form C, so you are pointing towards C. And it is important to know the definition of enthalpy change of formation. Okay, the enthalpy change of formation is going to be the enthalpy change when 1 mole of substance, please take note, 1 mole of substance is being formed from its elements at standard condition. So it means it is formed from the elements, but important is 1 mole is being formed. Okay, so in this case, okay, we are going to try to draw the triangle, yeah, the enthalpy cycle, Hess's law cycle. Okay, so we are going to represent. Okay, so in this case, we are going to first represent maybe to form. Okay, so you see the arrow, I'm pointing towards the H2O, okay, to form water. And how do I form water? I form water through hydrogen. The element is hydrogen, which is going to be the gas, okay. And then I'm going to form from oxygen. I want to form 1 mole of H2O. So therefore, okay, this one, I want 1 atom of oxygen, so I put half over there. Okay, so this is going to be the enthalpy change of formation of water. So I'll just leave it over there. And then, okay, we can have another line, okay, to show the formation of what? Okay, the formation of the urea. Okay, in order to form urea, okay, what do you need? Okay, the element 1 mole of urea. So the element that you need is going to be 1 mole of carbon. and you can see oxygen, okay, one atom of oxygen, so it must be from the element of oxygen, okay, in gaseous form. So we have to put half because we want one atom of oxygen. And then, okay, we have nitrogen, N2. You can see from the equation over there, N2. So the element is nitrogen gas. And then I have the element of hydrogen, okay, but do remember the hydrogen over there is different than the hydrogen over here, yeah. So that hydrogen is for water. So here, the hydrogen, you need 4 atoms of hydrogen or 2 moles of hydrogen gas. So we need to put 2 there. Okay, in total, okay, what we can do, we can make it simplified, okay, by okay, we can simplify this, okay, half O2 plus another half O2, that's going to be 1 mole of O2. Okay, so I can simplify 1 mole of O2, and then we can also have carbon, okay, the carbon over there, I have simplified this. I have also hydrogen, 1 mole, and then I have 2 moles, so I can make it as 3 moles of hydrogen, and I have the nitrogen. So what I can do over here is I can clear this off, okay, but do remember, okay, before I clear everything off, this is going to be the enthalpy change of formation of urea. Okay, so I erase this part first, okay, and I can actually put, okay, this as our new box. Okay, so I just put this as our new box. And then, okay, I can change this, okay, into I can change this into a bigger arrow, or one single arrow. Okay, so let me erase this first. Okay, so I can bring this enthalpy, so basically I can represent this entire thing, okay, as, okay, one particular, okay, reaction. So I can select and bring the arrow somewhere in the middle. Okay, so I'll just bring it here. Okay, so we have that. Okay, so if you want to extend, yeah, this one, okay, is going to be, okay, forming this box. Okay, and this is going to be represented by these two. Okay, enthalpy change, and therefore, okay, there should be another one. Yeah, so therefore you have the enthalpy change of formation of what? There is also formation of carbon dioxide. So let's see for carbon dioxide. So the arrow, it should be forming towards this box. So let's see. To form carbon dioxide, you need carbon. So I have carbon. Okay, no need to rewrite again. Oxygen. Okay, so I have oxygen. And then I have 2 atoms of nitrogen, so the element is N2. Okay, and then I have 6 atoms of hydrogen, so 6 atoms of hydrogen from the element of hydrogen gas. So therefore that is settled already. So it means that this one I just need to put enthalpy change of formation of what? Carbon dioxide, enthalpy change of formation of ammonia. Okay, but do remember, enthalpy change of formation means 1 mole of ammonia is being formed. So each of them 1 mole, 1 mole, 1 mole. This is 2 moles. So this one is not only 1 mole of ammonia, enthalpy 2 times enthalpy change of formation of ammonia. Okay, that's the difference over there. So you make sure you put that. Okay, once you have this, okay, you can actually solve this. Okay, I will just the method that normally I will use is, okay, I will put the circle in the middle. Okay, so when I put a circle in the middle, okay, what I will try to do most of the time is to change the arrows that we have over here to follow the circle. So maybe I'll just change it a little bit to follow the circle. Okay, I will curve this arrow to follow the circle. I will curve this particular arrow to follow the circle. Okay, so what it will help me, okay, it will just help me to know that which one is a clockwise direction and which one is going to be anti-clockwise direction, because according to Hess'S law, okay, the total energy change is independent of the route taken. So in this case, the clockwise, okay, must be equals to anti-clockwise. So if you put it over there, okay, if I want to represent this and try to solve this, it should be enthalpy change of formation of water. Okay, you add enthalpy change of formation of urea, and then this is going to be also clockwise direction, enthalpy change of reaction. So I'll just put enthalpy change of reaction equals to anti-clockwise, so which is going to be enthalpy change of formation of carbon dioxide plus 2 times enthalpy change of formation of ammonia. Okay, and when I have this, okay, what I need to know is just need to replace the values. Okay, when I replace the values, enthalpy change of formation of water is going to be negative 287. Okay, plus formation of urea is going to be negative 320.5. Okay, enthalpy change of reaction is what we want to find. Enthalpy change of formation of carbon dioxide is going to be given negative 414.5. And then this one, be careful, 2, yeah, 2 times enthalpy change of formation of ammonia, so negative 81. Okay, so you just need to solve this, okay, and you will find the enthalpy change of reaction. Okay, so you try to solve this. Okay, I will rewrite this again. Okay, 2 times negative 81. Okay, you bring all this to the side, so it's plus. So plus 287 plus 320.5. That will give you a value which is kilojoule per mole. Okay, I have calculated this in advance, so let me double check this answer. So this one is plus 31. Yeah, so I'll just put it over here. Okay, so plus, you can calculate yourself, 31.0 kilojoule per mole. Okay, that's the answer. Okay, but this answer is going to be by using the typical way of solving, which is going to be by drawing the cycle, and after that, okay, we try to solve and calculate. Okay, that is the first method. So let's see, okay, how we can use the same method, how do we solve the same question, okay, with a different method, which is going to be another method, which is going to be, okay, which is going to be the rearranging the equation. So let's try that. Okay, okay, let me bring it over here. Okay, okay, let's actually, okay, hold on. Okay, so I'll bring it here. All right, so the second method, okay, is going to be rearranging the equation. So in order to do this, okay, first, okay, we just need to write the equation again, the main equation. So I will write the main equation, which is going to be H2O, okay, plus CO and H2, which is your urea. Okay, and then after that CO2, okay, plus 2 NH3. I'm not going to write the states for now. Okay, now I am going to, okay, solve this by writing equations. So the second method is make sure you write the equation. So in this case, formation, yeah. So in order to know this, okay, formation, your definition must be very strong. Enthalpy change of formation is 1 mole of substance being formed, okay, from its element. So if they say enthalpy change of formation of water, it means that to form 1 mole of water in liquid form, you require, okay, from the elements of hydrogen gas and oxygen gas. And okay, you want the 1 mole, so what you need to do, you just need to put the half over there. So therefore, okay, this one, if you want to write it down, okay, it's going to be, okay, so let me put half O2 there. Okay, so here, okay, of course, if you want to write it down, okay, go ahead, gas, this is liquid. Okay, so this value is going to be negative 287, okay, as given. And then the same thing, let's do the same thing, CO, okay, NH2, and then 2, which is going to be in aqueous form. Okay, the value is going to be negative 320.5. Okay, to form this urea, it means you need the element, which is element is carbon in form of graphite. Okay, graphite is the stable form. Okay, and then oxygen, okay, that's 1, so I just put half O2. Okay, and then nitrogen, N2, so I just put N2, and then H2, that's 2, so I'll just put 2H2, sorry, 2H2. Okay, just, okay, to make us able to see this clearly, I'll just try to make it bigger. Okay, maybe we can write it down a bit, yeah, but we'll just leave it here first. Okay, of course, oxygen is gas, nitrogen is gas, hydrogen is gas. So let's actually quickly do for the carbon dioxide the same thing, yeah. Okay, carbon dioxide, you get it from 1 mole of carbon, and then the element is going to be oxygen, so no need to put half. Okay, 1 mole of O2, yeah. So all these are going to be this is graphite, okay, graphite, and this is going to be gas. Okay, and then you are going to get the in form of aqueous over here, they already gave. So ammonia, okay, so to form 1 mole of ammonia, in this case they say aqueous, it's okay, doesn't matter. It is formed from the element nitrogen and hydrogen. Okay, so you have one atom of nitrogen over there, so I just put half over there, and then you have 3, so you just need to put 3 over 2 over there. Okay, so 2 and 2 cancel, you have 3 atoms of hydrogen, so both of these will be gas. Okay, so basically all these values will follow the value that is given. Okay, so this is the equation. First, write down the equation. The trick of this method is going to be, we are going to rearrange this equation, like we are going to take it as puzzle, yeah, like trying to solve this in a puzzle form. Okay, we just take it as, okay, let me, okay, in this case, hold on. Okay, we try to actually take it, okay, as though we are trying to solve, okay, all this, okay, as puzzle, okay, puzzle pieces, and I'm going to solve this equation. So if you look over here, okay, first of all, okay, I am going to have ammonia. Okay, so in this case, what I need to do is, okay, I need to make sure I look for, okay, ammonia. Okay, so how do I look for ammonia? Okay, you look for the equation that involves ammonia. So this one is the ammonia, and then you check, okay, the position. Two things that you need to check: the number, okay, of the moles in front, and the position. So if you look over here, the position is going to be on the right. You see, this is the reactant, this is the product. So this is the product. It's okay, no need to worry about the position. But the number, okay, you see the final equation, there's 2 here, there is only 1. So what I need to do, I need to change this entire equation. I need to times by 2. So what will happen? Okay, half times 2 is going to be 1, okay, and 2. Okay, 3 over 2, okay, times 2, you will get 3H2. Okay, and then ammonia times 2, I will get 2NH3. And what I will have in total over here is going to be, previously is negative 81. So because I times by 2, I need to put like this. Okay, this is the delta H. And then the this is, I have already solved this. Okay, let's look at carbon dioxide. Look at the puzzle pieces. Okay, which one has carbon dioxide? So I can see here carbon dioxide. The position is on the right. Okay, the number is the same. So what I can do, I just straight away write the same thing, because there is no change. Okay, so I'll just write down, okay, what is given. Okay, so I have solved for carbon dioxide. Let's actually look at urea. Okay, urea, if you look over here, urea, okay, 2 things that you need to look, which is going to be the position. Okay, the position is on the left now. Okay, here is going to be on the right, so you need to change the position. The number is the same, yeah, so 1. So I change the position. So when I write down CO, okay, NH2 to give you carbon plus half O2 plus N2 plus 2H2. Okay, I will just bring this to the side a bit so that it's nice to see. Okay, I put this, and then the value, okay, is going to be, because I changed the position, okay, the position, since you change the position, important to remember, okay, previously it was negative, so now because we changed the position, we are flipping the equation, therefore it will become positive 320.5. From negative become positive. Okay, very important. And the last thing is going to be water. So let's look for water. Okay, the one that will give you water is going to be this one. And the position is here in product. Okay, I want in reactant, you need to flip similar to just now. So I will write down as H2O to give you H2 plus half O2. Okay, the number of moles is still the same. So when I flip that, it will become from negative to positive. Okay, so you have this value. Now, if you do this, okay, if you do this correctly, okay, what you can be certain, okay, is going to be if you add all these values, okay, you are going to be able to get the correct answer. Yeah, so it means if you can get this value, okay, you can get this value if, okay, you add or total up all this value. So like for example, if you want this, okay, delta HR, okay, is going to be negative 81 times 2 plus negative 414.5 plus 320.5 plus 287.0. You will get the answer. Okay, and if you check our previous working, okay, you can check, okay, 2 times negative 81, okay, 2 times negative 81, negative 414, okay, negative 414, 320, 287, 320, okay, 287. So you will get the same value, okay, if you calculate, okay, which is going to be positive 31.0 kilojoule per mole. This is going to be rearrangement method. Okay, basically the idea is, okay, when you rearrange, okay, what happens, okay, when we add all this equation, okay, when you have all this equation number 1, equation number 2, equation number 4 and 3 and 4, okay, the total equation, it will give you this particular equation. So how, okay, if you still in doubt, actually you no need to do, yeah, but if you still in doubt, okay, you can always check. You see on the left is n2, you can cancel with this n2 on the right, okay, and then you have what else you can cancel. You have, okay, h2 and 2h2, 3h2, okay, on the left is 3h2, so you can cancel. And let's say carbon, okay, on the right, okay, carbon on the left, you can cancel, okay. And what else, okay, I think we can just rewrite this again. So it means here, okay, CO NH2 plus O2, okay, and then H2O is going to give us 2NH3 plus, okay, carbon dioxide, this one done, and then half O2. Okay, and let's actually simplify this further, see whether we can simplify this further. Okay, so O2, okay, we can rewrite this as, okay, we can rewrite O2 as 2 over 2, yeah, because 1 over 2, yeah, so I'll just rewrite 2 over 2 is 1 over 2, yeah, sorry, 2 over 2 is 1 over 2, yeah, so just now it's 1 over 2. Now, so what I can do is I can bring this like maths, okay, over here is minus, okay, so 2 over 2 minus 1 over 2 is 1 over 2, yeah, so I can cancel this part, okay, and I will have the 1 over 2 O2 there. So generally what we are going to have over here is, okay, you have the equation, okay, which is the same equation, should be the same, okay, you can see here, okay, here, okay, I think there's a mistake here, O2, yeah, we miss out, okay, we miss out another, okay, sorry here, yeah, so here there is no O2, why, okay, because of we miss out, okay, this is going to be, okay, this part is going to be 1 over 2 O2, 1 over 2 O2, that's going to be 1 mole of O2, and then 1 mole of O2, you can cancel, you can cancel, you can cancel left and right, yeah. So eventually you are going to get this particular reaction, which is, okay, the same as, okay, what we want to follow, yeah, what we are going to solve, yeah. So this particular equation, okay, is the same as this equation, and we have calculated for that equation as well. So this is rearranging the equation method, okay, the method number 2. And then let's actually have a look at the final method, which is my method, Mr. Gopi's method, but this one I'm not going to claim it. Yeah, so it's one of the method. Okay, maybe other people also use the same method also. Yeah, but this method normally I will use it, okay, whenever we are dealing with enthalpy change of formation. So please take note. Okay, for formation it's better to use this method, because this method I find it a little bit faster. Okay, the method is going to be, first, okay, you write down H2O, okay, plus CO, write down the equation that we want to find. Okay, so you rewrite. And the method is if your values all the enthalpy of formation. So this method is going to work when all the enthalpy of formations are given, or sometimes they give you few enthalpy change of formation. But for elements, please take note, elements, they are not going, enthalpy of formation is going to be 0. So they are not going to give that enthalpy change of formation over there. So we just need to put it as 0. Okay, but the element must be in standard state. Yeah. So here, okay, what we need to do is, okay, as I mentioned to you earlier, A plus B to give you C. Formation means, enthalpy change of formation means 1 mole of substance being formed, okay, from its element under standard state. So the arrow is pointing towards C. Yeah, so A plus B to give you C. Yeah, formation of C. So the arrow is pointing towards C. So what I'm going to do here is, okay, this is enthalpy change of reaction. Yeah, the one that I'm going to find. For formation, you are going to form water, you are going to form urea, you are going to form carbon dioxide, you are going to form, okay, ammonia. So the arrow is pointing towards them. Yeah, and this is, each of them are going to be enthalpy change of formation, but for ammonia that's going to be 2 times enthalpy change of formation, okay, of ammonia. Okay, because it's 2 moles. Yeah, so now what we need to do is we just can use the value. Okay, so water is negative 287, urea is negative 320.5, okay, and this one is negative 414.5, but this one need to be careful, 2 times enthalpy change of formation, negative 81. Okay, so 2 times negative 81. So what we are going to do according to Mr. Gopi's method, yeah, of the formation method, yeah, so in the middle, okay, we are just going to put the circle over there. Okay, so this is going to guide us, okay, on how to apply the Hess'S formula. So Hess'S law. Yeah, so we are going to actually change to follow the circle, yeah, the curve. Yeah, we are going to do the curve similar to the first method earlier. Okay, this one is going there, this one is going there. So now, okay, the method is going to be similar. Clockwise is always going to be anti-clockwise. So if you are too into digital clock, you do not know which one is actually clockwise and anti-clockwise. Okay, normally in your class or in exam hall, yeah, we are still using the analog clock, so you can see which one is clockwise and which one is anti-clockwise. Yeah, so in this case, okay, you can see we just need to put the negative 287, okay, plus negative 320.5, okay, plus enthalpy change of reaction equals to negative 414.5, okay, plus 2 times negative 81. So if you want to find the enthalpy change of reaction, so I'm going to rewrite this again. So plus 2 times negative 81, okay, plus 287 plus 320.5. Now, if you look at the previous examples or the previous working, negative 81 times 2, you see negative 81 times 2. And then negative 414, yeah, 0.5. Yeah, so you have that same as well. And then both of these are positive. 287 are positive, okay, 320.5 positive. So it means same working, of course, they will have the same answer, positive 31.0 kilojoule per mole. Okay, so basically, okay, it's just telling us that in the same question, okay, you can apply 3 different methods, okay, which are going to be, the first method is, okay, by drawing the Hess'S law cycle, the enthalpy cycle. The second method is going to be rearranging the equation. And the third method, okay, you can call it Mr. Gopi's method of the formation method. Okay, so you can use the formation. If it is formation, yeah, put the arrow and then you put whether they're clockwise or anti-clockwise, and you try to solve it. Okay, the third method will be very useful when we are dealing with enthalpy change of formation. Okay, but rearranging equation will be more suitable when we are dealing with other types of enthalpy like combustion, neutralization, and so on. Okay, so this one I will leave it to you guys. Okay, which method that you feel you're comfortable to use. Okay, but in exam, okay, the conventional method is still fine. Yeah, if they ask you to use the conventional method, which is going to be draw the enthalpy cycle, then after that you calculate. Okay, but if let's say MCQ, or let's say they didn't mention anything, okay, you can either choose the rearranging of equations or my method. Okay, but for my method, okay, probably you can check, yeah, if they give you many enthalpy change of formation, you can use my method. Okay, but if there is something else and so on, I think the best method is going to be the rearranging the equation. So please choose, okay, or you get used to what method that you want to calculate the Hess'S law calculation. Okay, and then you can choose any method, okay, as long, okay, you show that you are still using the Hess'S law, okay, which is going to be enthalpy, total enthalpy change is independent of the route taken. Okay, with that, okay, I will end our today's lesson. Okay, so if you have not subscribed, okay, to our channel, make sure you subscribe. Okay, and if you like this video, of course, yeah, we will appreciate. Okay, I will appreciate if you press the like button. And if you want to ask any questions or you have any suggestion for our future videos or something like that, you can write in the comments below. Yeah, thank you everyone. Bye.